Okay, so let's continue with exponential growth and decay. This is the same thing as here. The only thing that's changed is inside where our b was, we have two things. So a is still going to be your initial value. But when we do growth and decay, we're often talking about money. Okay, not all the time, but a good chunk of the time. So this will be our initial amount. So whatever that is, if it's something like bacteria cells or money or air inside a pool raft, something like that. And then this time R is typically going to be the rate that we're growing at or decreasing. And this will be a percentage that we want to make into a decimal. The only thing different between the growth and decay is the growth has a plus here and the decay has a minus. You will be given this formula on the test. The T is going to stand for time. What did we change? It was X, but since this is for real world, T right there will be time. So go ahead and flip over your page. We're going to rewrite the formula again. So Y equals A times 1 plus or minus, if it's decaying, R, which is your rate, and T is time. And I will go ahead and label these. A is going to be your initial or your starting. R is going to be your rate. We want to take percent to decimal. And T is going to be time. Remember, if I want to take a decimal into a percent, so if I had 5%, if I want to take that into a decimal, I take the decimal point and I take it 2 spots to the left. So this would be the same thing as 0.05. Take it to the left, tack on the extra decimal, and tack in a 0 there. Okay, so let's go into our first example. A fully inflated child's raft for a pool is losing, so this is decay, 6.6% of its air every day. So this is going to be our rate. So 6.6, let's make that into a decimal. I know it is a decimal, but it still is a percent, even though it has a decimal point. 2 spots to the left. So new decimal point, tack in a 0. So it's going to be 0.066 minus that. The raft originally contained 4,500 cubic inches of air. So this is going to be our initial. Write an equation to represent the loss of air after T days. So we have Y equals our initial value, 4,500, times 1, this is decay, so minus 0.066 was our rate, to the power of T. Now we can simplify inside this parenthesis because this is just subtraction. So Y equals 4,500, 1 minus 0.066 will be 0.934 to the power of T. So this is our equation. If they asked us to put this in function notation, I would change the y into f of whatever variable I used over here, because over here I used t, and put the t right there. So this is the function notation version. Part 2 says estimate the amount of air in the raft after 7 days. So we're going to say when t equals 7, what happens? Or find f of 7. So in our formula, f of 7, we're going to plug in 7 for t. 4,500 times 0.934 to the power of 7. I'm going to plug that all into my calculator. I'm going to be really good about using parentheses. So parentheses 4,500, close parentheses, parentheses 0.934, close parentheses, to the power of 7. So I'm going to use this little caret button, power of 7. See, it looks very similar to what I have here, and press enter. It didn't tell me where to round to, so I'll just round to the nearest tenth. So 2 is in the tenths place. The 3 behind it says stay the same. So our answer is 2,790.2. And what is this? Amount of air, it said cubic inches before. So this will be inches to the power of 3. That part's not super important, so if that throws you off, I would not count you wrong by leaving it like this. Do make sure you box in your answer. Okay, next one. This one is going to run into the next page. The next page is just graphing it. This one's really important. It's pretty similar to the one on your performance event. It says a college's tuition has risen 5% each year since 2000. The tuition in 2000 was $10,850. Write an equation to represent the amount of tuition T years after 2000. Okay, so 5% and it's rising, so it's growth. So we're adding, and let's move this. So I already did that up there kind of. Let's show it again. Move it to the left 2 spots. So the new decimal point's here, and add in a 0 in that spot. So 0.05. And let's write our equation. Y equals initial value first. So how much did we start with? Tuition started out at $10,850. Multiply by the rate. So 1 plus, because it's growth, R is your rate in decimal formation. Don't put 5. This should always be a decimal. 0.05. Close parentheses to the power of t. Adding those together, I'll get 10,850 times 1 plus 0.05 is 1.05 to the power of t. Over here, I could put y, or I could put this in function notation, f of t. Either would absolutely be fine. Now it says predict the cost of tuition for this college in 2020. So time is not 2020. Time is after 2000. So we're really saying this is 20 years later. So we want t to be 20. So let's plug in 20 for t. So 10,850 times 1.05 to the power of 20. Let's plug it in. Don't really have to put parentheses around the first number. Power of 20. So it's risen. It's now $28,000. That increased fast. 28,788. And this is money, so we should go 2 points after. 0.28 dollars. So 20 years later, that's how much the tuition at some college. Okay. Oh, here's our next example. See, if you're given a bond worth $3,000, this is the one that's most like the one on your test. If you're given a bond for $3,000 for graduating high school, the value of the stock increased, so growth, 1.5% per year. So I'm going to take this decimal point 2 spots, so 0.015. We're adding that. Here's our initial. Let's write equation. Y equals initial value, 3,000, times its growth, so 1 plus our rate. our interest rate is 0.015 to the power of t. Combining our like terms, we have y equals 3,000. 1 plus that is 1.015 to the power of t. Flip it to the backside. We're going to use this equation on the backside, so I'm just going to go ahead and rewrite. So rewriting that equation was y equals 3,000, 1.015 to the power of t. It says create a table to represent how much stock will be worth in 5 years. Then graph and label each axis. So let's go, so this is our x's, this is our y's. Let's go ahead and start at 0, 1, 2, 3, 4, 5 years. Perfect, after 5 years. So this is saying plug in 0 in for t. So in my calculator, I'm going to type this in. 3,000, parentheses, 1.015, close parentheses, caret symbol, 0. $3,000. 0 years in, my bond is still worth $3,000. Now, my calculator allows me to not retype all of that, so if you have to retype all of that to do the next one, you can, to the power of 1 now. Now we're plugging in 1 for t. We get $3,045. I'm going to press second enter because that allows my calculator to retype it all without me having to do it. If yours doesn't, pause and type it in. Let's do the power of 2. Okay, so first time we went up $45. The next time we went up, so 3,090 and 68 cents. I rounded to the nearest hundredth. The 5 behind the 7 said go up. This time we went up $45.68. So this shows me that even though it jumped up quite a bit the first time, it jumped up very close to the same, but if this was linear, this would be 45, not 45 and some change. Okay, so this is exponential, even though it's a slow growth, because 0.15% is not, or 1.5% is a small percentage. So let's go ahead and find the other values. Plugging in 3 for t, 3,137 and 4 cents. Plugging in 4, $3,184.09, and 5, $3,231.85. Okay. So 5 years later, I've gained $231.85. Now we want to create a table here, or a graph. Remember, always label your axes with words first. So our x will be time in years. Our y will be value in dollars. And we need numbers. So my time, I'm going to go 0, 1, 2, 3, 4, 5. And now my value, I don't want to start at 0, so I'm going to put a break in my graph and start at 3,000. Okay, and then I only need to go to 3,230, so I'm going to go up by 50s. That should be good. 3,050, 3,100, 3,150, 3,200, 3,250. That's plenty because I need to go 3,230. Now when I graph these, I'm expecting it to look close to linear, but not exact. And I'm going to have to estimate a little bit. So 0, 3,000, that's here. The next point, 1, 3,045. So right to 1 up to 3,045. So between here and here, there's 50. So it's not quite all the way to 3,050, but it is below it. I'll zoom in on my graph now. Okay, the next point is 2, 3,090. So somewhere maybe about here. 3, 3,137. Maybe about here. We have 4, 3,184, maybe about here. And maybe about here. So we're gonna, something like this. And I know over time it's gonna start turning, so I'm gonna create a little bit of a wave in my graph. The last question says, predict the value of the bond when you're 23 years old, assuming you graduate when you are 18. So let's see what the difference is. I got the bond at 18. We want to find out what we're going to plug in for t. So how many years have passed from 18 years old to now 23? Well, let's do some subtraction. Time would be 23 minus 18, and that is 5. So we want to know when t is 5 times 5, what happened? So we plug that into the equation. Well, just did that right here. So our answer's kind of right there already. Y equals $3,231.85.